So we all talk to AI, right? But have you ever stopped to think about where it actually lives? Today, we're going to pull back the curtain, go past the slick software, and find the massive, humming, global infrastructure of supercomputers that makes it all possible. Let's follow the signal. Think about it. You type a prompt into a chat box, you hit enter, and poof, an answer just appears. It feels like magic. But here's the thing. It's not magic. Your request is taking an incredible journey, sometimes zipping across continents to a brand new kind of factory. So what is really going on inside that black box? You see, the power behind today's AI isn't what you'd find in your typical data center. Nope, we're talking about something else entirely. These are purpose-built supercomputers engineered from the ground up for the insane demands of artificial intelligence. So what really makes these new AI factories so different? Well, it's a huge shift in their basic architecture. A traditional data center uses CPUs, right? You can think of them as versatile problem solvers, kind of like a jack of all trades, great for juggling lots of different tasks. But AI supercomputers, they rely on thousands and thousands of GPUs, the same processors that power high-end video games. And that's because GPUs are absolute masters of parallel processing. They can tackle one enormous problem by smashing it into thousands of tiny pieces and solving them all at once. That's exactly the kind of brute force you need to train a modern AI. And you gotta think of it like a Formula One car. It's not just about the engine. Every single component has to be perfectly tuned for maximum performance. You've got the GPUs, which are the workhorses, but they generate so much heat they need incredibly advanced cooling just to survive. You need storage and networking that are lightning fast just to feed these things data without causing a traffic jam. And of course, you need a massive amount of power to keep the whole show running. It's this whole system where every single part is pushed to its absolute limit, all working together like one giant cohesive brain. So when you have this incredibly powerful and incredibly expensive technology, the big question becomes who's building it and where. Because this isn't just another corporate trend. It's shaping up to be a strategic global competition for the future of technology itself. You know, it might sound a little dramatic, but many experts are calling this an AI arms race. And in this new era, the most critical resource isn't oil or steel anymore. It's raw computing power. Nations and corporations are literally scrambling to build and control this infrastructure because they see it as absolutely fundamental to their economic and national security. And this is happening everywhere, but often with very different goals. In Memphis, you have a private company building Colossus specifically to train its Grok model for a commercial advantage. But then you jump over to Finland, and their Lumi supercomputer is a public project serving researchers all across Europe. You see Kazakhstan launching a system for digital sovereignty, while the UK is pointing its new machine at national priorities like improving the NHS and decarbonization. It is truly a global phenomenon. And just to give you a sense of the scale of these investments, look at this number. $200 million. That's the price tag for Oregon State University's new AI complex, and that was kicked off by a massive gift from NVIDIA. And remember, that's just one university. We are seeing investments of this size and way, way larger from governments and private companies all over the world. Okay, so we had these incredibly powerful, globally distributed machines, but what do they actually do? I mean, how does all this compute power actually translate into real-world change? Well, let's start with our critical infrastructure. The modern energy grid is unbelievably complex, especially now with renewables like solar and wind creating all these fluctuations. AI systems can process real-time data from the entire grid to predict demand, automatically reroute power to stop blackouts before they start, and even spot energy theft, making our whole system more stable and more resilient. In the world of science, the impact is nothing short of revolutionary. At the University of Miami, for instance, researchers used an AI supercomputer to run these incredibly complex simulations for new HIV drugs. What used to take them days of work now takes a matter of hours. This kind of insane acceleration is happening all over the place, in medicine, climate science, materials research, and it's totally changing the pace of discovery. The impact on business is just as staggering. I mean, look at this quote from JP Morgan Chase. They used AI to analyze loan agreements, a task that once took 360,000 hours of human work. It now takes them seconds. That's not just a little improvement, that is a complete transformation of how work gets done. And governments are jumping in too. The IRS is using machine learning to detect billions of dollars in tax fraud that humans would miss. NASA is using generative AI to design more efficient, lighter parts for spacecraft. From disaster response to citizen services, AI is helping the machinery of government run faster, smarter, and more effectively. But, and this is a big but, this incredible power comes with a whole new frontier of risk. As we become more and more reliant on this centralized AI infrastructure, we also create new and in some cases much scarier vulnerabilities. This is where the cybersecurity game gets completely flipped on its head. For decades, we've been focused on protecting networks, right? Building firewalls. But with AI, the whole attack surface shifts. Attackers aren't just trying to break into a system anymore. They're trying to manipulate the very logic of the AI model. They're trying to corrupt its mind. And this leads to totally new types of attacks. With data poisoning, an attacker can secretly feed a model bad information while it's being trained, creating a hidden vulnerability. Adversarial attacks are almost like optical illusions for an AI, tricking it into misidentifying what it's seeing. And prompt injection is where a user crafts a really clever prompt to trick a language model into bypassing its own safety rules and doing something it's not supposed to. And these are not just theories on a whiteboard. The financial stakes are staggering. A company in Hong Kong lost $35 million. $35 million. All because scammers used a sophisticated deepfake video to impersonate senior executives in a conference call and convince an employee to authorize fraudulent money transfers. This is the new reality of AI-powered crime. And the risks here go way beyond just direct attacks. There are these huge systemic issues, like a model that's trained on biased historical data, which then spits out biased results. There's supply chain risk, where a single infected open-source tool can be downloaded by thousands of developers. And of course, you have state-sponsored groups that are now actively targeting the AI infrastructure of rival nations as a new form of warfare. All of these individual risks really point to a single, much bigger question, one that researchers call the AI control problem. As these systems become exponentially more powerful, how do we guarantee that they will continue to do what we actually want them to do? And this really gets to the heart of it all. The danger isn't necessarily some Hollywood-style evil AI that hates humans. The bigger, more subtle concern is a hyper-competent AI that pursues a goal we give it, but in a way that has disastrous and unforeseen side effects. It's not a problem of malice, it's a problem of misalignment between its goals and our complex, often unspoken human values. So that leaves us with what might be the central question of our time. We are building the most powerful tools in human history, and we're connecting them into a global brain. The challenge now, the challenge for all of us, is to make sure that as this intelligence grows, it remains a force for good, truly aligned with the values and the well-being of its creators.